a deep dive into the science and engineering behind a rooftop solar system. When you are planning to install a solar power system, whether it is a full-scale solar farm or just a rooftop setup, your first priority should be how much sunlight does that particular site actually receive. This is not about guessing or just looking at a sunny day. We use a scientific measure which is called solar irradiance to evaluate this. Solar irradiance tells us how much solar energy is falling on a specific area at a specific moment. It is measured in watts per square meter. Think of it as the intensity of sunlight shining down on your roof. The more intense the light, the more energy your solar panels can convert into electricity. To measure solar irradiance, we use one instrument which is called pyranometer. It measures all the sunlight falling on a flat surface, including both direct radiation and diffuse radiation. Direct radiation means sunlight that comes in a straight line from the sun, and diffuse radiation means sunlight scattered by clouds and particles in the atmosphere. The term GHI here stands for global horizontal irradiance. It is the total amount of solar energy received per square meter on a horizontal surface over a specific period, usually measured per day. So the unit we use here, kilowatt hour per meter square per day. In India, good GHI range is from 4.5 to 5.5 kilowatt hour per meter square per day. In Singapore, GHI ranges from 4 to 4.5 kilowatt hour per meter square per day. It is slightly lower due to regular cloud cover and humidity in this coastal country. This is another interesting topic related to solar panels. Before solar panels come to the market, they are tested under controlled conditions, which is called STC, standard test conditions. In labs, solar panels are tested under these conditions. The first one is 1000 watt per meter square irradiance. Means the solar panel is placed under a calibrated light source. We call it solar simulator that emits light at an intensity of 1000 watt per meter square on the panel surface. Second test condition is AM 1.5 solar spectrum. What is this? AM stands for air mass. It measures how much atmosphere sunlight travels through. If it is AM1, means sun is directly overhead, means the rays is most intense. And in AM 1.5, sun is considered at 48-degree angle, means the sunlight passes through 1.5 times more atmosphere than AM1. In STT testing, we use AM 1.5 because it reflects typical sunlight conditions in many parts of the world, including India, Singapore, Europe, and the US. So next condition is 25 degrees centigrade cell temperature, which means the temperature of the solar cells must keep 25 degree because solar panel performance drops as temperature rises. The lab measures how much electric power in watts the panel produces at that moment, and that measured output becomes the panel's rated capacity. For example, suppose if a panel generates 330 watts under these STC conditions, so it is labeled as a 330 watt panel. So this standard testing allows us to compare panel performance fairly using the same light and temperature in all tests. The next important concept is inclination angle of solar panels. Inclination angle or tilt angle of a solar panel is the angle between the panel surface and the horizontal ground. We can see here in this figure. This is the panel surface and this is horizontal ground. So the angle is 30 degree. It is one of the most important factors that affect how much sunlight the panel receives and therefore how much electricity it can generate. Solar panels produce maximum energy when the sunlight strikes them perpendicular, means 90 degree. But the sun's position changes with latitude. Near the equator, the sun is almost directly overhead at noon. So flat or gently tilted panels work best. As you move towards the poles, the sun appears lower in the sky. So panels need to tilt more upward to face the sun directly. Have you noticed the inclination of solar panels installed in Singapore and India is different? Singapore is located at approximate 1.3 degree north latitude, which is very close to the equator. Here, the panels are placed almost horizontal, parallel to the ground, or these are kept slightly inclined around 1 to 5 degree maximum. And this slight tilt is given to allow water drainage and reduce the dirt accumulation. India stretches across a wide range of latitudes. Northernmost point at 37 degree latitude and southernmost point at 8 degree latitude. So India lies roughly between 8 degree and 37 degree north latitude. If we talk about capital city Delhi, it is around 28.6 degree north, and Mumbai is about 19 degree north, and Chennai is around 13 degree north. So that means the ideal tilt angle for solar panels varies by region. In northern cities like Delhi, panels are typically tilted around 28 degree as per the latitude. And in central or western India like Mumbai, the recommended tilt is around 19 to 20 degree. And in southern cities like Chennai or Bangalore, the panels are tilted lower at around 12 to 15 degree. So for installing solar panels, the general rule of thumb is best inclination angle will be equal to latitude of that particular location. Solar panel efficiency. Imagine your rooftop solar panel is a sponge, but instead of soaking up water, it is soaking up sunlight. When we say a solar panel is efficient, what do we really mean? Solar panel efficiency is simply about how well the panel can convert sunlight into usable electricity. For example, suppose if a panel is 20% efficient, it means out of all the sunlight it receives, 20% gets turned into electricity and the rest is either reflected or lost as heat. So here is the formula to calculate the solar panel efficiency. So efficiency in percentage is equal to P out divided by A into G into 100. So P out is the output power of the panel in watts. A is the area of the panel in square meter and G is the solar irradiance in watts per square meter. Let's see a real example. Imagine we have a solar panel that produces 340 watts of power and it has a surface area of 1.7 square meter and it is tested under STC condition, means 1000 watt per meter square sunlight. So now with this formula, if you calculate the efficiency, so it will be 340 divided by 1.7 into 1000 into 100. So it will come 20%. So this panel is 20% efficient, meaning it converts 1/5 of the sunlight it receives into electricity.